Thanks, folks, for listening in today. Just a quick uh, question or comment that why are we even talking about extending CNC when, why can't we have everything built into CNC, right? So the short answer for that is that any vendor that's trying to build a platform that's solving your problems, it'll be very hard for anyone to build anything that can do everything for everyone, right? I mean, it's just a simple, statement here. What we want though is that we want a platform that does, things for this particular space, the IP network uh, services turn up and management. We want something that can be doing things good for, like, let's say, get you started with 80-90% of what you want, and does it, it's well tested and well qualified with a wide variety of Cisco products and latest and greatest technology innovations that are coming out. And then has a way of being extended to fit your needs, right? Because not everybody's needs the same. With automation, we want simplicity, but we also want to solve our business problems. Everybody has slightly different spin on it. And then we definitely want to have control over which vendor routers we're going to deploy in which areas. So multi-vendor is always important. Now, as John said, we have always had NSO to do the provisioning piece, but with CNC, we have added visualization, service health, and a lot of things. So let's go ahead and kind of review. In the last 2 days, meaning early today and yesterday, we actually had multiple presentation about Crosswork Network Controller, both from the aspect of we have NSO, what does it, what do you get when you go up the stack with CNC. Yesterday we had Nelson, Deepak, and Sujay present some things. Early today, Paula talked about assurance, and Nicola covered a lot about what we can do with element management, right? But in short, you have CNC, which is this big gray box here that's talking to your routers, your IP MPLS routers, or in more and more, we are seeing IPv6 core-based routers running SRv6. And then you want to be able to interact with your network through a common API or common UI, right? That's what the black layer is your area where you're going to build your own software that will be driving your network through APIs rather than having you to be aware of every router's variations of CLI configs or operational elements such as mid paths and YANK paths. You want something to abstract it. That's where CNC comes in for the IP networks, right? And inside of it, we have a lot of things that we do, but starting from the top is basically service and transport provisioning. These are your VPNs, your traffic engineering based on the SRTE with MPLS or SRv6, or your legacy RSPTE. This is where we use, NSO quite a bit, and basically this is going to turn up a service and do modifications, create update delete CRUD as we call it. But that's just the day one, if you will, or day two when the service comes up. Your operations team, and this is why we are in the operations track here, is using CNC to manage the network, to keep it alive, to respond to customers, to be able to collaborate with among themselves to either make changes, to provide constant uptime, and basically be aware proactively of what the customer would be experiencing so that you can reduce any kind of outage times and have the experience high, right? That goes into the a number of things, but you started with visualization. If a network engineer can see the topology of a network and the service overlaid on it, that cuts down a lot of time in terms of a human to be able to absorb the information and to then take the next steps, right? And then when you go into traffic engineering, you're going setting up paths to very specific, with criteria. So is it even working as you expected? Instead of logging into tens of routers to check, what is the next hop, you want to be able to nicely pictorially see it. So can you do all of that, right? That's the thing that CNC actually brings to the table. And then you have a series of things that are really needed for keeping the network working. Element management, network element, a router needs to be, deployed in the field. Zero touch provisioning helps cut down the number of effort to do that. Software and image management upgrades, all your FCAPS type of capabilities, fault alarms, performance indicators, and inventory. Nicola covered quite a bit about what all we are able to connect to the routers, get the live inventory, and feed it to you, so that your business systems, your inventory tracking systems can use APIs and collect that. And this is live, meaning we are actually telling you what the router is telling us, right? Instead of you having to write code to go and get that info, we have it out of CNC. So that would be the element management features. When you get to traffic engineering, path calculation is a big thing, right? Some entity has to know all the network and the bandwidth patterns of usage, and then has to be able to respond to your intent-based, criteria to say pick certain paths that can actually satisfy your intent, right? So that engine is the path computation engine, and it has to be always up and always optimizing, meaning any path that it calculated and gave it to the head-end routers to inject traffic into that path, network events happen, links go down, nodes go down. That original intent should be honored by constantly recalculating paths under those circumstances and keeping the original intent paths up, right? So this is always on the running. For your services that are up, that are provisioned, that these are your customer-facing services, could be your L2 or L3 VPNs. For large SPs, there are quite a number of those. For large enterprises, there are a few of those. They don't change much. But end of the day, you do need to know that for what our client to deliver a transport service, what is the client experiencing? That means you have to constantly check the assurance of it. And you have also check maybe by sending some sample traffic, what the customer's traffic will experience. So you need all of that to be integrated in one controller to do that. And in the past, a lot of these things were done in silos. You would build separate tools. Every department with their own operations team would have its own siloed products, and your turn-up service turn-up may have a separate one. But with CNC, we're trying to do all of that in an integrated fashion. How does it do that, right? Again, you might have seen this slide in the last few presentations. But in short, you have the network at the bottom, the multi-vendor network devices, and we want to interact it using CNC. So inside of CNC, we have built a highly scalable microservices-driven architecture-based software, right? So this is basically using Kubernetes inside, but we ship it as a VM so that you don't have to worry about a lot of the Kubernetes-centric DevOps that would be needed. We have been asked in some cases to get to that level of interfacing with a pipeline that the customer you yourself will set up, and we give you the artifacts that you then integrate and test. But a predominant number of our customers are actually requesting some kind of abstraction where, keep it simple, give us an infrastructure as a service interface so that we deploy, on top of a simple VMware or AWS EC2 kind of infrastructure, or even KVM, right? So all of those are deployed, but the system itself brings up a lot of these nodes and then install the software, modular software. As you can see, there is provisioning module, visualization, optimization, service health, and so on. In terms of how we talk to the routers, which is where we need to be aware of multi-vendorness, right? We want to use standards-based protocols to talk to routers from point of view of getting the layer 3 topology and the path computation related conversation between the controller and the routers. We are using these protocols, the PCE protocol and the BGP link state. These are standards-based protocol. Most modern routers are supporting it. And this can be used for both your segment routing based MPLS and segment routing based traffic engineering, or even for RCPTE. And then in the CNC complex, these are actually implemented as XR based routers, because it's actually the ability to talk PSAP and BGPLS south to your routers is already built into XR. And so typically we recommend XR v9000s to be deployed, and we have integration on the top that is a internal integration that can actually drive collection of this topology, link state DB from all your ISIS and OSPF domains, and also being able to push down the traffic engineered path using PCE protocol. We do need a big data collection layer, because anything that you want to do that is aware of traffic patterns in your network would need telemetry collection, right? And in the GNMI-based telemetry collection is the most state-of-the-art, and we support it. We do see that a lot of the networks are still not fully up around to support GNMI. SNMP is kind of the least common denominator. We also need to collect alarms and syslogs, and we need to collect inventory information. So there's a lot of things that we use telemetry layer. And this is implemented as a scalable layer. So depending on how you scale your VMs, your network, you deploy a number of data gateway VMs that will be attached to those devices and collect those. Then we have your configuration engine, which is our NSO platform, which connects to the routers either using CLI or netconf and can configure it. So let's look a little bit deeper on the provisioning aspects. So when we talk about provisioning, we are actually talking about VPN and traffic engineering in IP transport networks, right? So very simply, we can do a lot more things. For example, your day zero config, golden configs, and things like that. A lot of those are already part of NSO, but in terms of abstraction, this is what I'm talking about from the CNC's point of view. And this is done by using a Cisco NSO inside of CNC. And if you let's recap what benefits that NSO brings us and how it brings it, right? It's a model based, and YANG models are used to define the service as well as the device models, right? So there's a little bit of abstraction of how you express your services in YANG models, meaning if it's a L3 VPN, you just need to know the nodes of the names of the nodes at which you're delivering that service, the interface names. You don't need to know the actual configs on the routers, right? That would be the job of the device model, to be able to understand the device's dictionary of how to configure anything. And then there is a translation layer that's needed for a device agnostic model to a device model entry, if you will, right? As a device, service instance data that needs to go on a per device information. All of that should be very familiar to a lot of the NSO focused, developer audience. But just bringing it up, kind of saying that we're using the exact same thing underneath the hood on CNC. The fast map code is what's doing the transformations, and then we can actually talk to more than 170 types of devices because there are nets available for those. Now, one thing that to note is that CNC comes with its own set of NSO function packs, the TSDN Core Function Pack, Transport Software-Defined Networking Core Function Pack, which provides you out-of-box L2 and L3 VPN, segment RTT, SRv6, RSPT. So you don't have to start from a zero to build your NSO capability to provision anything. You can start with the core function pack and then just do modifications, which is where the extensibility aspect comes in. So where do you need to extend? You need to extend it in two scenarios. One is that whatever the service model is doing, which is a plain vanilla VPN, you have your own flavoring of it, which is a little bit more advanced. You would want to add a few more things in the router configs, or carry it right from the northbound interface down to the device. So you would add more things in the YANG model. So that'd be an extension. That would require a transformation, the fastmap code extension or a template extension, all that is part of NSO development. You may want to support non-Cisco devices, right? So what we ship out of box covers iOS XR, iOS XE, right? But if you want to do any of our other, competitor vendors out there, your Junipers, Nokias, Aristas, or whoever you want, all of those, you do need to do the extension part to customize the template for that particular device model, and then the code to implement that. So that's something it's done very commonly in NSO land, meaning that if you're an NSO developer, you already know how to do it. And if you're an operations person that is using a multi-vendor network, you have to, that that's possible. Yeah, a lot of our customers do it themselves. We have partners that are doing it. And in this demo, we are going to show an example of it. And in this example, what we're going to show you is that the left side, what you have in this picture, the red parts are what is shipping out of the box. And this is the customization or the extensions that are added, which is the on the right side, which is the orangish thing, which is for a Juniper router that we'll be using in this demo. In this example, we will go a little bit fast, a little bit high level, but if you want to know how the actual package was implemented, we showed this in the Developer Days conference back in November 2022. So you may want to go ahead and look at that YouTube video that I have linked in this slide. Now, one thing to note is that if you're thinking about CNC and bringing it to in your environment, there are really three scenarios to think about, right? One is that you're building a brand new network, greenfield, that network doesn't exist. Now you're building it. So now you'll provision services from get-go using CNC and NSO, right? That's a very simple scenario, meaning you would take all the things that we ship with the CNC, the NSO comes blank, and then you load the CNC TSDN function packs, and you can start provisioning your VPNs and traffic engineering policies. If you find you need more like extensions to it, you can do it, and it's a very minimal effort work. The next thing is you already have running a network, you already have VPNs deployed, but you were using a homegrown tool or some other vendor's tool, or maybe no automation for creating these services. That would be an existing network, but a new NSO, and then on top of it, CNC is coming in. So for that, what you have to do is that first is you install the software suite that we are giving you, which is the NSO and CNC, and then you do an exercise to reverse map your device configs into L3 VPNs and L2 VPNs and the key policies that you have. That reverse mapping, there are some design patterns and implementation patterns you can follow. And of course, our professional service can do that. It's usually a one-time effort to create a reverse mapping template because, depending on how those things were configured, there's still probably a template or has a little bit of guesstimate and iteration would be needed to create these. So it's not easy out-of-box automation here. But once you do this one-time job, then your state on the NSO is built for all the existing services. That from that point, you manage it from CNC NSO. And finally, if you have already an NSO in your network and you're already using it to provision your VPNs, and you've implemented this package either yourself or with your partner or with Cisco CX that predates the availability of the core function pack, you can still use that. CNC will sit on top of it. There are some additions needed in this kind of packages to give CNC the plan data and the notifications that we need. So there are additional standalone packages that can be added on top of your package to add this, augment this information to your package and send it to CNC. And then this basically enables a current NSO user to get benefits of CNC relatively quick, right? So that with that you get visualization, traffic engineering, service assurance, element management that we talked about earlier today. And when you talk about visualization, what are we talking about? How is it going to benefit, right? We'll look in the real live demo as well, but in short, you can see a VPN that is, all the points of where you're delivering service, like a VPN visualization by clicking on a VPN, and all the, let's say, metadata or data like route targets and things like that can be also rendered. And there is, what we call as decoration that you can add based on the service instance data on this in this UI. When you look at traffic engineering view, which is a bottom view, this is where you can actually click on a traffic TE path and see hop by hop it being resolved and shown on the UI. You can click on details and look at all the, let's say, MPLS labels we're using, SRTE or RSVT or SRv6, you can see the IPv6 paths. There's a lot more in terms of visualization. You can visualize inventory, as it was shown earlier by Paula, as well as alarms can be overlaid, right? Now, the key thing to note is that these visualizations may also need extensions, right? As you change your YAML model for your service, you may want to extend the visualization as well, because what happens is that the visualization follows the service model. And basically, it's it goes and looks at the service model, and then it says these are the routers that are PEs, and it decorates them with those colors and links and these things. And whatever we are shipping out of the box with CNC, it already takes care of the visualization, right? But you can also use your own extension to those YAML models, and in that case, there's a visualization SDK. Either you're just adding more things on the UI or you're changing the YAML model. So those are the two scenarios that you would need to use this particular SDK. That link is clickable to look at our documentation. If you're just adding other vendor routers southbound, the northbound interface doesn't change, so it doesn't need any visualization changes. And then there's a link of what we showed about how to take a YAML model that is not shipping with CNC. So totally independently developed YAML model and a service, and to add visualization. So if you want, if you're interested in that, please look it up. Finally, going into service set, right? So service set is something that we added on top of CNC, mainly to help assure a particular service by service, right? Usually the problem is that your operations stacks are built independent of your service tenant stack, which means that your operations team is collecting all kinds of traps, logs, or anything that a router may emit. But nobody is very confident on saying, is this trap going to impact my service A or service B, or is it like impacting my top secret high premium government or military carrier circuit that I'm giving? How do you get a service specific assurance, right? That's where we started looking at, how to do this. In the past, it would be to take all the alarms and then try to figure out if that particular alarm on that particular router and that interface may be given to somebody. That's called the mapping server approach, where there's some kind of a data that you have populated saying, this is the config I've given, to each customer. And then if anything comes from those things, that may be an alarm for those. We have changed the model a little bit with RFC 9417, where we took this concept to IETF and debated it and discussed, and it got RFC standardized. The model is that you created the config, meaning the service intent is already known. So that's why you can actually also calculate the KPIs for that service on all the components that are actually delivering that service, right? So that's what is that's why we call it service assurance for intent-based networks, SAIN, SAIN, right? If you think of the service as in this picture, for example, it's an L2 VPN, depends on like a cross connect status. It depends on the attachment circuit status. It depends on binding to a SR policy or RSVT policy underneath. If you have data path assurance using Y1731 Ethernet SLA, we can actually use that to also feed it into the service state, right? So what we have done is we've built an automation engine inside CNC. What it'll do is, as soon as you configure a service, we know the service configuration model. We have an equivalent rules engine that will map it to a service assurance model, right? As soon as it knows it's a type L2 VPN, it needs to check all of these things using the components that that service is using, like what are the routers, what are the attachment circuits, what are the IP addresses, and so on. And what it does is that it automatically sets up telemetry collection and starts collecting it on a periodic basis. And this is not like hours, but this is more like in minutes, right? Every 5 minutes if it's SNMP, every minute if it's GNMI telemetry. And so it gets all this constant feed of this service-specific telemetry, which it runs through a logic to determine whether it's healthy or not healthy. That logic can be, viewed by the operator to get a view of historical how it's behaving. Particularly if it's a time series data in terms of like delay or packet loss, you can see nice graphs to see how it's behaving. And if anything is crossing a threshold, that will be a threshold crossing alert that's sent so that humans don't need to sit and stare at screens. They are notified when there's something that the system has detected, so you can actually jump in and start looking at it. So we have some references of some information we have shown. What I'll jump quickly to is a set of demos. In this case, we're going to add a Cisco router, non-Cisco router, and we have chosen a Junos Virtual MX router. And in this case, we're going to provision a L3 VPN by using the packages that are needed on SO, and then we're going to show you the service health monitoring. So what are the summary of steps we did in this demo is that we loaded on the NSO side a Juniper Net. That's an network element driver that you can get from Cisco to talk to a Juniper device. We have sample packages that are implementing the L3 VPN and SRTE, and then we are going to add the Juniper VMX router to CNC. Then we're going to provision, and then we're going to also do service health. For service health, we're going to show you that if you're doing open config YANG, there is not much to needed. You just export the rule set that we call it as heuristic package, and then you edit. But if you're doing a vendor-specific MIB-based object, you have to actually load the other vendors' MIBs into the system. So I've covered a lot of it. We'll see how far we get. So the starting point for this is that a lot of this will be done in production networks, either through our professional services or our partners, or by yourself with some training from us, right? For this demo, what we've done, we have developed some packages. We have put it on GitHub that you can actually access and see. So this GitHub is public. You should be able to get it. We have sample implementations of provisioning L3 VPN on all these vendors, segment routing TE on all these vendors. And then the way you deploy this on a router is you just pulled out this package, and then you either use CLI to install it, or you can actually sure why it hanged, but yeah. So what I'll switch to in the interest of time is I've already loaded those packages on the NSO. The way you load packages on NSO is very simple. You can actually download those packages and install it, and then wire opt NCS packages, and then you do packages reload, and then the package will show up. So in this case, on the CNC side, we have paired it up with this NSO here, and you see here all the packages that are loaded. And let me first show you that I've loaded those packages. By the way, the GitHub shows you some information on how to install and there are some post-install steps that are also done. It's all documented in the GitHub README. So you see all these packages are loaded. So that's number one step. The number two step would be that we want to actually map a software type to this particular net, right? So if we go into this, we have a policy or device onboarding policy, which says, as soon as detect a software of type ISXE or ISXR or Nexus OS, you start using these device drivers to talk to those devices. So added this entry to say if it's for type Junos, then you use this net, right? So that's the next step. Then finally, we can onboard the router itself. So if you go in here, I've already onboarded it, but I'll show you the key things to do here, which is, you can click edit and then you can see here, in this case, the router itself will be auto detected using L3, because we are going to onboard the PCE, which is going to get the layer 3 topology. But in this case, you have to go ahead and add the software type and version. We can detect that using SNMP, but usually it's a long string, and we are adding features to let you specify regular expression patterns to pull this information out of those strings, like what show version on Cisco would produce. And of course, you need to provide all the management credentials and capabilities that this router has. At the end of this, you will basically have a topology view with this router added. So in this case, this is the router. And all of these node 1 to 8 are Cisco ISXR 9000 virtual routers. And this VMX is the Juniper V virtual VMX router that's been added. As you can see here, it's detecting some of this through SNMP. You have the alarms here. We have the links here. You can actually click on a link to see that we are actually being able to collect more information about the links, both from Juniper and Cisco side, of what's connected and some of the metrics. Okay, now let's switch to the services, right? So we want to create a service, and I've actually gone ahead and create this service. The way we create service is that you can actually go ahead and use the provisioning screen. Let me quickly show you this screen here. And here are all the packages that are available in NSO are shown. The action, the workflow to create the service is exactly same as you would use for Cisco or non-Cisco. And in this case, what I'll switch to is a window where I have the payloads, right? So we can use an API call, or we can even load the API, the JSON for these creating the service into the UI itself, right? So this is how, if you did it through API, you would create the JSON, right? So you have a IETF standard structure, L3 VPN network, service name. We are going to import, export the same route targets. So it's any to any. And then here's the route policy. We're going to color these routes in the BGP color community. Here's the PEC interface, the VLAN to be used, the P side IP address, the C side IP address. We're going to use BGP. We're going to use connected. And then I'm going to scroll down to the Juniper side, the VMX9, and you see all of the same type of information. There's really no difference here. So let me go back to the screen. So I have it already created because it in the interest of time. The first thing I want to show you is that if I click on the service, you're going to see a visualization where you're delivering all this service. And like I said, you can decorate this view with any additional information you want. When I click extended overlay, you can see the route targets here. You can go into view details, and then you will see that you have transport tab. And if you go to config tab, you will see that this is how basically I copied that file, the JSON file down. If you use the UI and click through and fill in all the data, then you can go and copy this JSON back, and then you can use that from going forward, or you can give it to your business system that will make API calls to provision it. If you look at transport, this is where you will see the TE parts, right? We colored these routes in with BGP color community, and we also put the segment routing on-demand next hop template, which says that on each head end, if you get a route with a color 4003, bring up a SRT policy for color 4003, which has some criteria in it, right? And you can see we have a Juniper head end here to a Cisco tail end. In this case, I'll just click it, and you can, as soon as you click it, you see the path here. And you can go into view details to see a lot more information about how this policy was created and information that you can see here. The UI is running a little bit slow, not sure. There you go. And then you can see here, let me push this to the side. This is how a dynamic path, on a Junos router looks like. If you're familiar with Juniper, then you will see this is what we are able to collect and show you. The path itself was created using some criteria which you can scroll down and which result in all these MPLS labels, segment labels being used. You can see router and the interface, and then the criteria here, where you can basically use any criteria. This part, it works as if it's the router supports standard-based approach technologies. Now, last thing to look at is service health, right? So you can already see that we are able to collect service health data. You can see the health is good, it's successful. We are using a monitoring setting called bronze L3 VPN. So you can have gold, silver, bronze kind of capability. And if you click on this, you will see, some of the thresholds that we're going to compare against for bronze, which can be different from gold, etc. And then if you go to health, you'll see that everything is healthy. There is no active symptoms. And you can actually go into assurance graph to see that we have a number of things that we are checking, and let's expand all because to show you, and then we have something called soft dependencies. So these are the only things I implemented in this demo, but in reality, it can be anything, any number of things you want. We have two flavors of out-of-box: a basic that checks for L3 VPN, just device health, and then the VRF health, meaning are we getting routes from remote PEs. Now the advanced one checks the PEC interface, like health, like counters, errors, packet drops, BGP sessions, and if you're binding it to SR policy, it will also check the SR policy health. All of this was done by something called heuristic package. So when you go to heuristic package, this is the rule set. You can click export here. These are just JSON files. You can edit them, which is what I did. So I changed the basic ones, customized it. And let me just jump to the device health because we have time to just show you probably one of them. So here's one example of how to collect CPU health from the routers, right? So in this case, this is how the actual metric is collected. So you can see here that there are implementations for SNMP with iOS XR, which is this particular MIP path. It's a vendor-specific map. If with SNMP with Junos, I have the Junos map mentioned here. If you want to do it with GNMI, we have a Cisco-specific YANG path for Cisco. We also have an open config-based path for Junos, right? So the pattern is very simple. You can edit this. It's a text file, like I said, again, it's a JSON file, and then editing this, and then you tarball it and import it back, right? So this is the import export. This is a kind of pattern you'll be doing: export, test, import, test. And as an engineering team, your team would probably do this and then set it into production. And ops team doesn't have to worry about it. Ops team will basically just use that UI to see just the service health. Now, there's one more step. Because we used a Juniper vendor-specific MIP, you have to load this here. We call it custom packages. So there are custom MIP packages to load. And the pattern to develop this is actually documented in our webpage in the SDK area. If you go to DevNet and look at Crosswork, you fill custom YANG and MIP files. Basically, it involves downloading a bunch of other vendor MIPs, and I have them here. And then this is the basically file, right? If I do a find dot here, you will see that I download a bunch of Juniper and Nokia MIPs. And then you tarball it and load it there, and then you get that. And then the other thing to show you here was the heuristic package itself, which is here. So these are the files that we ended up creating for this particular demo to show service health working with non-Cisco, right? The Junos VMX. So these were the files we did. This is what I had planned, and I know I'm kind of over time here. We covered this. You're having the slide. I have a summary of the operational models things here. That's all I had. Sorry for running a little bit over. John, any thoughts, questions?
Well, thank you, Krishnan. Yes, we're a little behind, but I think it was really super valuable information. I mean, we've been saying how the product has multi-vendor capabilities and customization capabilities. All of our customers, typically have some, wrinkle where it's not going to be a complete, Cisco shop, greenfield services, which would be nice, but there's always going to be some customization required, and again, thank you for sharing that. There were a few questions. Let me just hit one that seemed to have gotten a couple thumbs up. Does the Cisco Health functionality support many more checks than shown? For example, TWAMP over VPN or BGP session state. Can you add, additional checks into the service health portion of this?
Yes. So what I showed you was like I said, there are two flavors of service checks that ship out of the box. The basic, again, it's a scale exercise, meaning if you want to do pervasive, just use basic because it does three KPIs. One is the health CPU memory, and the other one is the route counts, right? The reason is that and the advanced one does like about 20 checks, right? Which includes the PC interface health, the PC BGP session state, the IBGP for VPN v4 v6, and the PSEP session if you're using binding to policy. It does add a lot more load to your telemetry and collection. So from scaling perspective, we gave you two flavors. And of course, you can add more checks as you want into it. We have a option to also add TWAMP checks. TWAMP checks with external XCDN-based probes. XCDN integration is available in 7.0, which is the latest shipping release. And in this case, basically, we are able to set up TWAMP sessions from this SFPE or software agent to agent, and then collect telemetry and present it in the same view. We also do embedded for Ethernet SLA. We can configure those Ethernet SLA sessions on the routers itself and use the delay variation packet loss as it's counted. And then there is something called segment routing PM that iOS XR supports. So we also collect that, and we can use that also for.
Perfect. Okay, Krishnan, thank you again. And again, all the decks will be available for review. So I know you went through a few slides at the end there fairly quickly, but those will all be available for folks to take a better look at.